What if you could use your brain signals to control a robot to perform certain actions? So, Stanford researchers have come up with a system which can use brain signals to control a robot. So, here is a demonstration video where they're using brain signals to control a robot to cook sukiyaki. Okay. So, how are they doing it? Right. So, in their system, what they are doing is that there is an environmental display which a person looks at, right? And there is EEG recording of the person. The person thinks about a certain goal. Now, from that, they decode, from the EEG signals, they decode what object, how to interact, where to interact, and then this is converted into robots into control signals for robots with primitive skills. Okay, and then they are also trying to predict what is this human goal. Now, what is this useful for? This is useful for human augmentation. So, basically, supporting people with disabilities, senior citizens, and this could be useful also for general population. Okay. So, the brain robot interface systems are a challenging research topic, and there are a lot of been developments in machine learning, neuroscience, and robot learning to build novel brain robot interface systems. It is also about AI alignment to understand human goals, satisfy human needs, adapt to human preferences. They call this system as NOIR, which stands for Neural Signal Operated Intelligent Robots. And let's go to the system, right? So if you look at the system, there are three stages, I could say, over here. In the first stage, it is about what object to manipulate, which is decoded from SSVEP signals using CCA classifiers or object classifiers, right? Now, what does SSVEP stand for? SSVEP ECG data is nothing but, EEG data is nothing but, it is an electrophysiological measure that has been extensively used in studying attention to external visual stimuli. So, there is the visual part of, your EEG data. Okay. EEG stands for electroencephalography. It is used to measure the activity of human brain. Okay. So, they have electrodes which capture the activity of human brain, basically certain potentials. Okay. So now in the first stage, when a person looks at a certain scene, basically, right? Looks at a certain scene, it is displayed on this environmental display, and using OWL plus VIT, they are highlighting certain regions in that image, right? And they are made to flicker. Right now, the person looks at it, and based on the SSVEP part of EEG data, they do an object classification, and they also have this clench option to actually change the objects, right, over here in that particular image, right, which the person is looking at. Now, once the person has looked at it, now the person can imagine, like, I want to lift a particular object, right? Now that activity is captured in something called as MI part of EEG data, right? So MI data is generated when a subject imagines the movement of a limb. Okay. So in EEG, from EEG using this MI data, they can now identify, like, okay, pick from top, pick from side, or push a particular X. Okay. Now if the person were to imagine that left hand, he imagines the left hand, then it is pick from top. If it is right hand, then it is pick from side, right? So now that is available. Okay. Now the third stage is where to interact is again decoded from this MI signals. Okay, from the EEG, which is about move to right, move left. Okay, and they can also, as a safety mechanism, they capture the muscle tension from jaw clench, which is used to confirm or reject decoding results. Okay, so just by looking at a particular scene over here, with the EEG system placed on a person's head over here and the signals being captured, the person can now actually control a robot to perform certain actions. That is the whole point of this work. So what they're saying is that this human intention can be mapped to 14 parameterized robot skills such as pick, place, and push. Humans find novel use and combine these skills to accomplish hard tasks. Okay. And other thing they're saying is that decoding human intention is time consuming and costly. The robot learns human object skill and parameter selections in a few short manner. So human effort and time can be reduced as they perform same task in similar contexts. So they have a retrieval based few shot object and skill selection model. It learns a latent representation for observation. So given a new observation, it finds the most relevant experience in memory and selects the corresponding skill and object. Okay. So this is how they are reducing time in decoding the human intention. Yeah, some more details are given on how it is done using this is the image, training image, where they have a reference point in the training image, and how you are using Dino v2 tokens to actually predict on a test image that it should be this region which needs this particular object, and associated with certain skill can be retrieved, like pick bowl, right, or pick glass or something like that. So they talk about the various experimental results on various long horizon tasks. 4 to 15 skills everyday activities. 16 is 4 to 15 is everyday activities. Okay, over here in this picture. And then 16, number 2 to number 17 are tabletop also tabletop manipulation tasks. Okay, with Franca, and 4 are mobile, number 18 and number 2 mobile manipulation tasks, 18 to 21. Okay. The tasks include 8 meal preparation tasks, 6 cleaning tasks, 3 personal care tasks, and 3 entertainment tasks. So they are talking about these various tasks which have been accomplished. Right. And here are the various videos of how this robot is accomplishing these tasks. Collect toy, sweep trash, clean book, iron cloth. Right. So it is able to actually iron a particular cloth. Open basket, pour tea. So these are the various actions which are being performed. So basically the person is looking at tic-tac-toe over here and thinking about how to do it, and the robot is actually playing with the person over here. You look at this, right? Yeah, these are the things like mobile tasks, trash disposal, COVID care, water plant, pet dog. Right, so they talk about the results over here, and they have various FAQs on the safety of the system and other things. So what I will do is that I'll put a link to this website. You can go and check out for yourself. This is a very interesting work. So maybe in the future we will have an avatar-like system where our conscious is transported to an avatar, and it can perform various actions for us. Yeah, that is really too much into the future. But at least I would like to see a production-based system coming up from this, where you can actually control robots to perform certain actions in, say, dangerous environments where probably person cannot go, or for people with disabilities or senior citizens, to help them with their day-to-day activities, right? Yeah, I hope this video is useful for you. If you like the video, please like, share, subscribe to the channel. See you in another video.